Alright, free fall and accelerated motion. Okay, let's get some big ideas down. So we're going to let up be positive, and we're going to let down be negative. So next big idea, as you know, gravity pulls down. So that'll be in the negative direction. So acceleration due to gravity is also down, since that acceleration is caused by gravity. So on our coordinate system, the acceleration due to gravity is going to be pointing in the negative direction, in the downward direction. Okay, now the value of that near the surface of the Earth, we call that g, and it has a value of 9.8 meters per second squared, which oftentimes we round to 10 to make our math a little bit easier. So here in our examples, since we're calling the downward direction negative and gravity pulls down, then our acceleration is going to be negative g. Now velocities can be either up or down. So they're either up in the positive direction or down. So they can have either sign. And we're dealing with motion along a straight line, but we can go either direction on that straight line. And when we're talking about free fall, right now we're talking about things moving up or down in the gravitational field and responding to that. Okay, last couple big ideas here. For example, if you have a ball that is thrown upward, then gravity is going to slow it down. And recall that when velocity is positive and acceleration is negative, then we have slowing down. For a ball falling down, gravity speeds it up. So that would mean for downward, velocity is going to be negative and acceleration negative. So when the signs match, we have speeding up. Okay, so then some math to put to this. So let's start with the acceleration formula that we've used before. So change the notation just a little bit from our class. We'll say that the initial velocity is v0. And the velocity at some time later is v. So that'll be the final velocity. And t is just the elapsed time. Okay, so for free fall, our acceleration, our a, is going to be equal to negative g. In other words, negative 10 meters per second squared. So then we're going to rewrite this formula for free fall. So instead of a, we have negative g equals v minus v naught over time. We can solve this for v. So using a little algebra, we can get a formula for the velocity of an object that is in free fall if it has this initial velocity and has been free falling for some amount of time t. So t is the time spent aloft And this is the initial velocity. And this is the final velocity. And importantly, we are ignoring air resistance.